Okay, now we're in the sums of terms of sequences, and I got to tell you, there's a lot of examples. I really look for examples that help you through the homework quiz, and you know, I just couldn't condense it much at all. I think we wound up with a total of 14 or 15. But here's the thing. We've got something called summation notation, okay? And it's basically a shortcut. By the way, E is the Greek letter for sigma, and that's my guess, that because we're using it to represent a summation, that's why they're using that Greek letter. What this tells us is that we're going to start counting at some number, and in our example it's I equals 1, and we're going to stop counting at another number. And we successively add the terms. So for this example, we're going to start with I equals 1, and we're going to write the term x plus 3 times 1. Okay, and that's going to get added to, same idea, only now we're going to up the index of I, x plus 3 times 2, and then we're going up to 5. I'm going to show you to 3 plus x plus 3 times 3. Okay, and I could list out all 5 of those and then sum them up, but it turns out that when we have addition in our summation, then there's a shortcut. So this sum will be equal to n over 2 times a sub 0 plus a sub n. Now, a sub 0 is the first term, and I know that we start counting at 1, and that happens sometimes, but it's important that you remember that this is just the first term, and this is just the last term. So let's go ahead and calculate that first term, which is just going to be with I equals 1, which just gives us x plus 3. And we're going to calculate the last term, which our last index is 5, so a sub 5 is going to be x plus 3 times 5, which is x plus 15. Now we've got the numbers to fit into this, and by the way, n, if we start with a counter of 1, then that's our n, okay? So we're going to use 5 over 2 times x plus 3 plus x plus 15, which is 5 halves x, 2x plus 8. And I can divide that. I'm not sure. Now on some of these we can simplify. On some of the answers to the quizzes we have to simplify. On some of them we don't. Accidentally erase that. So I'm going to go ahead and simplify because 2x and 8 are both divisible by 2. So 2x divided by 2 gives me 1x. This will simplify to 5x. 8 divided by 2 is 4. 5 times 4 is 20. And that you can definitely enter into the quiz software. Okay. Expand the following. All right. So here's the thing. We don't really have any shortcuts unless we have something that is just addition. Our index is in the denominator of a fraction, and we're also squaring this, so there is no shortcut. Okay, and when they ask you to expand it, they actually expect you to type all of this in, and I think they're just trying to help us get used to the idea of what the meaning of this is. So let's start with I equals 1. So we're told that we start at 1 and then we go to 4. So for I equals 1, we're going to substitute an I in wherever we have, we're going to substitute a 1 wherever we have an I. So expanding this out is going to look like this. X plus 2 over 1 squared. All right, let's go on to I equals 2. X plus 2 over 2 squared. I equals 3. X plus 2 over 3 squared. And then I equals 4. X plus 2 over 4 squared. Now, believe it or not, you'd have to enter that whole thing in. I think it means that it's worth it to simplify this a little bit. So we get x plus 2 squared plus x plus 1 squared. This can't be simplified. And that's what you would enter. Okay. Same idea. Okay, we're gonna. This one's a little bit different. We're gonna start with an index of 3, and we're gonna count till 7. So just plugging in, starting with my index of 3 into the pattern. X minus 2 times 5, 5 plus 2. Yeah, I kind of need to keep track of my indexes. I equals 5, I equals 6. And I am going to simplify that because it'll be easier to type in. And I think the reason they want you to see this is because we've got to go the other direction on these patterns after we get this part down. They'll give us a sequence, and then we've got to get back to the summation notation. It'll take a while to type, but you got to enter it. All right, I'll see you on the next video.